Today we're going to be working on Leetcode question number 321, create maximum number. So you are given two integer arrays nums1 and nums2 of length m and n respectively. Nums1 and nums2 represents the digits of two numbers. You are also given an integer k. Create the maximum number of length k, which should be less than or equal to m plus n. Okay, from digits of the two numbers, the relative order of the digits from the same array must be preserved. Okay, return an array of k digits representing the answer. So if you have been given this 3, 4, 6, 5 and 9, 1, 2, 5, 8, 3, where the k is equal to 5, so the answer needs to be 5 elements long, and it should be the largest possible number with keeping the order, like we need to keep the order the same inside one number, but we can choose whichever we want. So which, like, we can actually choose the element which is gonna make this, which is gonna create the output the greatest number. So that's what we're gonna be doing. We're gonna be trying to create a biggest number from there, and a biggest number like from one element, and then checking if this is the still the biggest number, and we're gonna basically iterate through the two numbers, trying to get the biggest number out of them, and then and at the end we're going to be merging them together in order to come to this output, like the output which has the biggest, which has the elements which is going to create the biggest number. That being said, let's just have few variables here where the int, let's call n equals to the nums dot length, int m is equal to the nums 2 dot length. Okay, let's have an array where we're gonna be putting our solution or the final answer. Let's call it answer array, new int k. We know that the size of the array which we're going to be returning needs to be k. Now what we need to do is to iterate, because some numbers are going to be taken from like first array, and some numbers are going to be taken from the second array. So, and we need to merge them, right? So for that we're going to say that our I is gonna start from either 0 or k minus m, whichever is bigger. We're gonna be doing that. So in this case our m was 2, 3, 4, 5, 6. So 5 minus 6 would be -1. So that's why we're gonna be starting from I equals to 0. Okay, the second thing is it's gonna go up to k. We don't wanna separate them more than k, and I needs to stay. Actually, there is one more thing. It should be less than that. Oh, sorry. It should be less than the k, and it should be less than equal to n plus I plus plus. Okay, so now what we need to do is, like, first of all we're gonna have some candidates, right? Every single time when we get some numbers from nums1 and some numbers from nums2 and we are merging it, let's call this function merge, which is gonna basically take some numbers from nums1 and some numbers from nums2. So it's gonna take array 1, array 2 from nums2, and it's gonna take a k, because the way we're gonna be merging it is like based on that uh, that index k, that like because we're gonna be iterating our index in order to go up to k, and taking one number, some numbers from the array 1 and some numbers from the array 2, right? And that would be our candidate, which we want to check that, okay, is this the answer? That is one thing. Now the array 1, the way we're going to be getting the array 1 is actually the maximum number created from the nums1. So we're going to call another function called max array, which is going to take the nums1 and the I, and similarly the array 2 is we're gonna call another function called max array, which is gonna take the nums 2 and I. Oh, sorry, the length would be k minus I. And once we have created this candidate, right, we want to check that this candidate is actually has a bigger number than the current answer. So for that, we're going to call another function called greater, which takes the candidate, and it also takes an index for that candidate. We're going to always be using the 0th index on that, and the answer and the 0th index. If that is true, if it returns true, we're going to say that, okay, our answer can be switched to this candidate. Once we come out of this for loop, we can just return the answer. Okay, all we need to do is to implement these functions here. So let's do this merge one first. So once we do the merge, we are expecting it to return an integer array. Okay, what it takes is merge takes two arrays and one integer. So let's call the first array nums1 and the second array nums2 and an int k. What merge does is, like, again, because it's going to be returning an integer, like an integer array, and we know that the size of that is going to be equal to k. Okay, again, what it is gonna do is, like, basically it's gonna have this like, it's gonna iterate the index from 0, basically from 0 to uh, different k, like up to k, but it's gonna break down that k. So it's gonna break down that k, and then it's gonna once we are breaking down the k, we're gonna keep checking that if we still have if the number is greater or not, right? So based on that, if let's just say, so for let's just, because we are using 3 different indices, so all of them needs to int. There is an I which needs to start from 0, then, and I is gonna be the index for nums1. Now we need another index, j is equal to 0, which is gonna be an index for nums2, and then we also need to fill up this answer, so we're gonna call that r equals to 0. So that's how we're gonna start, but we're gonna say that r is less than k and r plus plus. Want to make sure that this stays less than k. So every single time the answer of r is gonna be equal to, we are checking that nums1 with I, nums2 with j, if it is true or not. If this one is, if we are getting true back from this greater function, that means that the answer of r is gonna be equal to nums of like nums1. It's gonna choose from nums1 I plus plus. Otherwise it's gonna choose from nums2 with j plus plus, and in the end we're gonna be returning this answer. Okay, now we're gonna be implementing this greater function. All it does is like let's just write the definition here. We are expecting a boolean back from this greater. Okay, it takes multiple arrays, nums1, and then the index for that, and another array nums2, and an index for that, and yeah, that's it. Yeah, we don't need the k for that. Okay, what it does is like it makes sure that uh, it makes sure, first of all, we don't, what should happen if the values of they are the same, like at the particular index, if the values are the same, we need to keep incrementing. So while the I is less than the nums1 dot length, right, and the j is less than the nums2 dot length. Well, this is the case, basically meaning that we are within the bounds, and the num1 of I is equal to num2 of j. So basically we're looking for the same elements. If that is the case, increment both of them and then keep moving forward. Other than that, we're just gonna check which element is bigger than that. So like which element is, if it is, basically we're checking that if the element the ith element in nums1 is greater than the jth element in nums2. So for that we're gonna just say that if they are equal, keep incrementing. We don't care about the equal elements, but we want to make sure that they stay within the bound. Okay, if they are not equal, we're gonna say that if this is equal to the nums, basically first of all we want to check that if one has gone out of bound, right, if they were equal and we are left with only one element, right, if that is the case, if return this, meaning if this is true, or either if this is true, or we can just say that the I is less than the nums of 1 dot length and the nums of 1 I is greater than nums of 2 dot j. All it is saying is like if this has become equal to the if this has become equal, like j has become equal to the nums2 dot length, we're gonna be just returning true. Otherwise we're gonna be looking at we want to check that the I is less than that and the I is greater than 0, greater than 1, then we're going to be returning true. Otherwise it's just going to be false. Meaning false, meaning that the second element, the jth element on the nums2 is greater than the ith element on the nums1. So we're going to be returning false. Okay, the last thing we want to do here is to implement this max array, this one. So basically it means that we are taking the we are actually going to be returning uh, we are actually going to be returning the x amount of or ith amount of greatest numbers in that num1, preserving the sequence. So we are returning an int array back, and we do take an array, let's call it nums, and let's call the length we want back is gonna be len. Okay, all we have to do is like use a stack here, because we have an array and we want to return the length number of len number of greatest or the biggest integers back. That's what we're trying to do, but we need to keep the sequence the same. Stack is equal to new stack, let's call it integer. So we're gonna go through int I equal to 0, I is less than the nums dot length, I plus plus. Okay, now all we need to do, first of all, we want to make sure that do we need to take things out of the stack or not. So while we have the size is while the size of the stack, however many elements over there are, and the nums dot length, like the length of the array plus 1, is less than that is greater than that length, right? So that means that what we wanted to enter into the stack is greater, right? While this is greater than the length, and again we want to make sure that all of length is not because of this length. There are elements in the stack, so the stack dot basically stack is not empty. And main thing is that when we look at the stack dot peak, this is smaller than the current element. In that case, we know that we want to remove element from the stack. Okay, once we are done keeping the proper size in the stack, we want to check that if the stack dot peak, stack dot size is less than the length, then we're just gonna be putting the element into the stack. Okay, once we come out of this for loop, we can actually create the result, call it new, and we know that the size is gonna be equal to length. Okay, and then we're just gonna keep taking elements out of stack, and this time we can actually because we are using, it's a stack and the order has been changed, so we are filling it backwards. Greater than equal to 0, I negative negative. Okay, and the result of I is gonna be equal to stack dot pop, and we can just return the result. Let's try that. Did not like the num1 over here. should be nums. Should be nums. Yep, of course. Too many typos. So there's an empty stack exception. We had been doing it for length minus, from starting from length -1, greater than equal to stack, negative negative, and then pop. We are popping it every single time, and the result is that. Okay. When we are putting it in, we are checking is starting from I0 to inums.length. We are checking that the stack size plus the nums length, oh, not +1, minus I. This should be minus I, and that length should be greater than the length. And then we are gonna be popping it, and then in the end we're gonna be pushing. Looking good. And it works.